Okay, let's go through one more problem with finding area under a normal distribution under a normal distribution curve using a z-score. So this next problem is the same problem with different numbers. So with the mean of human pregnancies being 266 days, standard deviation of 16 days, what is the probability that a pregnancy lasts between 241 and 291 days? So first of all, we want to convert the values of x, and this time there's two x's, using the standard normal variable z, and then finding area under the standard normal curve. So stop the recording, see if you can figure this out, and then push the recording and check your answers. So with the z-score, notice with the z-score that the z-scores are equidistant away from the mean. Notice that the z-score for the 241 is a negative 1.563, and the z-score for 291 is a positive 1.563. Now we can put either one of those numbers in the applet so long as we shade the center, and if we do that, we get a probability of about 88%. So it looks like about 88% of all pregnancies fall between 241 and 291 days. Okay. Now, next thing we'll cover is finding percentiles from a normal distribution. We'll be using the applet. Now, before I get further with this, if you remember what a percentile is, say for instance if my height is at the 40th percentile compared to all men, say in the United States, then that means that I am taller than 40% of all men here in the U.S. But that also means that I'm shorter than 60% of all men. But what we're going to try to do is focus in on those folks in this example I just gave that I am taller than. Okay, and we'll deal with that using the normal distribution curve, and heights are normally distributed. So for instance, here's an example. If needed, click on the area using the applet with the normal distribution curve so that the only area shaded in blue is on the left side of the left line. So if you just shade here first, then step number 2 is type in the percentile number in the decimal form in the area box. So if we, for instance, if my height's 40th percentile, I type in 0.40 and then I press enter, and then I have this area here. So this area here represents, in the example I gave, the men that I'm taller than. Okay, and there's a z-score associated with it, which is negative 0.253. Then the next thing I'll do is I'll use the z-score under the left red line and put into this formula here. Now this formula looks a little bit different, but it's not much different to the z-score. Instead of solving for z, we're just using basic algebra to solve for x instead. Define the value of interest, which is x, which is the percentile you're looking for. So if we had a mean of 266 days for pregnancies and a standard deviation of 16, we'd plug these numbers into this formula and then use the z-score that's here that we got from the applet, plug that in here to get the 40th percentile, which is 261.95. Okay. Now this is so remember, this represents that the 40th percentile of the length of a human pregnancy. That means that at about that point, about 262 days, that's a longer pregnancy than 40% of all other pregnancies, but it's a shorter pregnancy than 60% of all pregnancies. Then one more example I'll go with it is that what if we have something greater than 50 percentile? Then I'd recommend doing is making sure that these areas here on the applet are shaded. Then, like the last example, put in the percentile relative to in decimal form. So if it's a 90 percentile, put in 0.9. Then use this formula again. Now notice here that it's shaded, this whole area is shaded, so 90% on the left side is shaded from this normal distribution, and from there we use this z-score, so we plug that in here with the mean and standard deviation to get 286.48 days in terms of the 90th percentile for the length of a human pregnancy, which means that length of a pregnancy is 90% greater than the length of 90% of all pregnancies, but it's less than 10% of all pregnancies. Okay. So then the last thing I want to cover is QQ plots, assessing normality. Now I'm just going to briefly go through this, and I'm going to have SPSS plots here, but you can do the same thing with Excel as well. If you find that the dots with a QQ plot are lining up diagonally, you can assume that data is normally distributed. I have here is heart rate data that's typically normally distributed. But if you find something like this where they don't fall close to a diagonal line, that means that it's not normally distributed. Okay, and that is the last video for dealing with normal distributions.